Hello guys, in this video I will derive the formula for the energy stored in an inductor, and I will also tell you that what is this energy and where it is being stored in the inductor. Now first of all, I have drawn this inductor along with a cell and a switch. Now this resistance R is not connected externally. In fact, this resistance R is the internal resistance of this inductor. We all know that any inductor is being formed of a conducting wire, and conducting wire has itself some ohmic resistance in it. So this R is the internal resistance of the inductor, but we are drawing it apart from inductor in the circuit because it has very important role to play in this circuit. So to start this circuit, we are closing this switch. You can see, so this switch is being closed. Now we know that the power supplied by the battery. So as soon as we have closed this switch, some current will start to increase in the circuit, and at any instant of time, let's suppose the current flowing in the circuit is I. So the power supplied by the battery is V into I. Okay, so this power is being utilized into two forms. PS, this is PS. Let us give it some symbol. This is PS, and the energy which is stored in the inductor and the rate at which the energy is stored, let's suppose it is PL. So PL is the rate at which energy is stored in inductor. So this PL can be written as du by dt. Now we know that the dissipative part of this inductor is this resistance, which means that any energy loss which would happen across this inductor would be across this resistance, because this resistance is the internal resistance of this inductor coil. So this is the heat loss across resistance. So the power loss across resistance PR is equal to I square R. So we know that the power supplied by the cell will be utilized into power lost against resistance, power lost in resistance, and the rate at which the energy is being stored in the inductor. But we are concerned to find out the energy stored in the inductor only. So we are concerned with this power only. Now first of all, we know that as we have started the circuit, the current will increase, and due to this increasing current, EMF would be developed across this inductor with this polarity. Okay, so the power PL, which is the rate at which the energy is being stored in the inductor, is du by dt, and it is equal to E into I, where E is the EMF across this inductor and I is the current, instantaneous current flowing through it. Now we know that this instantaneous current is variable because current is increasing, and after some time it will become saturated. So we can write down the magnitude of EMF as L di by dt. So this power PL is equal to L di by dt into I. So PL is equal to du by dt also, and it is equal to L di by dt. Now integrating both the sides, we get du is equal to Li di, and again integrating from limit 0 to u and from 0 to I naught. This is u is equal to L. This I will be written inside the integration. So this is I square by 2. We know that the integration of I with respect to di is I square by 2. So the limit would be 0 to I naught, and I naught is the maximum current, which is the saturated current. So U will be equal to half L I naught square. This is the maximum energy which can be stored in this inductor, and at any instant, if we need to find out the energy, then we can say that this energy would be equal to half Li square, where I would be the current at that instant only. So this is the formula for energy stored in an inductor. Now, there are two important things to note, that as soon as, first of all, this energy is magnetic potential energy. This is magnetic potential energy, and this magnetic potential energy is stored in electric field, in fact magnetic field. We all know that electric potential energy is stored in electric field because it is a conservative force field, and similarly the magnetic potential energy is being stored in the magnetic field. Now where is this magnetic field? This magnetic field is being formed inside this inductor coil. We know that when the current will flow from this inductor coil, some magnetic field will be formed in it. So this energy is being stored in that magnetic field which is formed inside this inductor coil. So the first thing is, which is very important, that this energy is magnetic potential energy and it is stored inside the magnetic field of this inductor coil. The second thing, which is also very important, that if we will open this switch, if I open it suddenly, then there is a huge amount of current initially before opening this switch in the circuit, and as soon as we are opening this switch, this current will decrease very rapidly to 0. So if this current will decrease very rapidly, then the EMF would be developed across this inductor, and that EMF would be of very high magnitude. So that EMF would be seen across this switch, because the complete EMF of this circuit would appear at this switch, and there will be a arc or a spark which would be seen here across the switch, because this EMF would ionize the air between this switch, and it would make that air conducting for some time. So this discharging of this inductor would take place through an arc and across the switch if we will open the switch at any instant suddenly. So this is second very important factor. The third thing which is very important to note, that if we compare this inductor and resistance with energies, then we can see that inductor is a device which is which can be used to store the energy, but that resistance does not store energy. In fact, the resistance always dissipates, or it creates heat out of that energy. The important thing is also to note that the energy is being stored in this inductor only when the current is increasing in the circuit. So the energy will increase, energy will be stored in the inductor only when the current will increase in this circuit. So I can say that if di by dt is positive, which means I is increasing, then energy is being stored in inductor, and if di by dt is negative, then inductor would release this energy, and inductor would act as a source of energy, and it will lose all the energy. So energy would be released from inductor. So this was the complete analysis of energy stored in an inductor. We'll meet in the next video. Thank you.